Okay, in this third mini video, I'm going to show you guys the chemistry of how we can remove oxides of sulfur when they're made through burning. So if you're going to make a sulfur oxide, there's no way around it. We have to burn coal to make electricity so we can run all our stuff. That is definitely something I wish you guys were in class, because it's a really good debate to talk about fossil fuels. And should we use them? Should we not use them? What is the realism of using them? And definitely we're not at the point right now where we can stop burning coal in Alberta without billions and billions of dollars of infrastructure change. But anyways, so when sulfur dioxide is burnt, we can use something called calcium oxide in something called a scrubber. Scrubbers are put on within the industrial process to remove pollutants. And what happens is the sulfur dioxide and the calcium oxide combine, and we get calcium sulfite. So you can see all I did was smush the two together. Now, calcium sulfite, if it's slightly heated, this is wild, with a little bit of oxygen, you get calcium sulfate. And what's calcium sulfate? Calcium sulfate is chalk. It's actually a usable byproduct. So we can take this harmful pollutant, which causes smog. Now, this isn't this smog. He's from Lord of the Rings, okay? That's the guy that Bilbo fought, okay? This is the smog, the haze that hangs in the air. So we can take that, and by adding this special chemical, make a usable byproduct. You can also do the same thing with another oxide. So if we had sulfur dioxide and we're reacting it with magnesium oxide, you would get magnesium sulfite, and then a little bit more oxygen will give you magnesium sulfate. And if that sounds familiar, I don't know if it sounds familiar to you, that is Epsom salts. You can buy that in giant, huge jugs in London Drugs, and you put it in the bath, and you soak in the bath, and it's supposed to make you feel better. I don't know. I'm 6'3". I haven't fit in a bathtub since I was 11. So you short folk out there, you got an advantage. Enjoying bathtubs within your house, because it's super awkward for tall people to have baths, I'll tell you that, because you're scrunched up underneath the overhang where the water comes out, and you stab your shoulder into it, and you really don't even fit in the water. If you fill it up too much and you get in there and you displace all the water and it sloshes everywhere, and then you feel terrible about yourself. Okay, this is no longer chemistry. This is just my issues with body image. But anyways, so this is the chemistry of how oxides of sulfur can be removed by magnesium and calcium. A byproduct also of a lot of the gas in Alberta is pure sulfur. So there's other processes to remove just the actual sulfur out, and then we have stacks and stacks of industrial sulfur that are incredibly high. These are all over Alberta. Now, you just can't drive around Red Deer and see these, but they're out by different plants for sure. Okay, so that's the thing I'm going to end with, is that the reason why we're concerned about these oxides of nitrogen and sulfur is they lead to smog. It's toxic, it's an irritant, and it's led to breathing and respiratory problems. And with this whole COVID crisis that we're in right now, this actually has been a risk factor for people that live in big cities. The death rate of people that live in big cities with pollution is way higher than people that live in areas without pollution, because it's constantly irritating your lungs. Even the people that don't know that, it is. And people who live in areas with high levels of smog have a shorter life expectancy. There's greater instances of lung cancer just from the constant irritation of it. So the more we remove this stuff, the better it is. And we can't get away from it yet. We don't have the technology yet, but we have maybe some chemistry to limit the limit the problems with expunging this gas.